2018 AS Physics Unit 1. It's the last question, number 7. It's the roller coaster question, which basically means this is your work, energy, transfer of energy and power question, right? We're looking at potential energy at the top, kinetic energy at the bottom, etc, etc. So we have a motor with a power output of 65 kilowatts, 65,000 watts, pulling that carriage up. It gives us the mass and it gives us the time taken. Show that the work done by the motor in 32 seconds is approximately 2 meg, right? So don't forget, meg means 10 to the 6. It's a show me, right? So we're going to make sure we get to that answer of 2 times 10 to the 6. So we normally do power is work done per unit time. So if you rearrange that formula, work done is the power times the time taken. They've given us the power, 65,000. They've given us the time, 32 seconds. And that's very close to 2 times 10 to the 6. I've got 2.08 times 10 to the 6. Don't forget, work done, energy, unit is joules. Hence, so use that answer. Calculate the efficiency of the mechanism, assuming the carriages are momentarily at rest at B. So at this instant where they're at rest, all of that energy is potential, gravitational potential energy, mgh. So they've given us the mass, we know what gravity is, and they've told us the height is 42 meters. So the total potential energy at that point, at that instant when it's at rest, is the mass times gravity times height, which is this value here, 1.07 times 10 to the 6. However, it took us nearly double that to get up there, so that should give you an idea straight away of the efficiency. So work this out as a percentage of this, that divided by that times 100 is 51.4%, right? There's nothing too difficult there. And then the last bit, they're probably going to ask us to work out the velocity or something when it hits the bottom of the track. At B, the carriages become disconnected from the motor and the carriages move under the influence of gravity for the rest of the ride. In moving from B to C, I assume C is at the bottom, a distance of 36 meters, the carriages experience a mean resistive force of 2.8 kilonewtons. Calculate the speed of the carriages at C. Now normally they ask us to work out this mean resistive force, but this year we're doing it backwards. So that resistive force of basically 2,800 newtons acts over all of the 36 meters, okay? So the total resistive force is that value there, the mean resistive force, multiply the distance it is applying for. That times that is 100,800 newtons. Now at the top, we've just worked out, we worked out previously total potential energy at the top. Right, so when it gets to the bottom, we're going to assume all of that potential energy is transferred to kinetic energy, but we would have to subtract the energy lost due to resistance. Okay, so I get that GPH there, I take off the resistive force there, and that leaves me with what I'm going to assume is all kinetic energy at the bottom. Of course, that there equals a half mv squared. Bring the half over as a times. Divide through by the mass, which was 2,600, and then square root it to get rid of that, and I get a velocity of 22.6 meters per second. Right? Got to be honest, great question for 5 marks. Not a bad paper, this one. Hope you enjoyed it. See you at the next one. Adios.